I'm Andreea Danielescu, and I'll be presenting our paper, Iterative Design of Gestures During Elicitation, Understanding the Role of Increased Production. Gesture elicitation studies have often been used to design gesture sets for various applications and modalities, starting with stylus interactions and then moving on to touch, foot, and full body and free space gestures. These studies show participants a referent or an action's effect and ask them to provide a symbol or interaction that could result in the referent and response. Originally, these studies asked participants to produce one symbol per referent, or one one-handed and one two-handed gesture per referent. Gesture elicitation studies may suffer from legacy bias, however, in which people are heavily influenced by prior interaction modalities. One such example is the hover gesture, which was used by the original Connect and is highly fatiguing for free space interactions. This limits creative gesture production and makes it more difficult to uncover gestures that take full advantage of the capabilities of emerging modalities. Several modifications to gesture elicitation studies have been proposed to address legacy bias, including the use of visual and kinesthetic priming, increased production, and the use of partners. In prior work, we introduced unlimited production, which does not impose a limit on how many gestures a participant can propose for a particular referent. In that study, we found that participants often preferred the third gesture they produced, and that as the study went on, the gestures diminished in variety. One open question that remained was whether increased production elicits gestures which are unbiased by prior experience, or whether latter proposals are just irrelevant variations of prior ones. Noting in the paper, consider production. Does it truly increase the variety of proposed interactions, or are downstream proposals from the same participant simply minor variants on earlier ones? These results have led to subsequent studies implementing increased production in a variety of ways, with several researchers asking participants to produce at most 3 gestures per referent, while others asking for at least 3, and yet others asking for a range between 2 and 5. Research has produced contradictory outcomes on the effect of increased production on legacy gestures. In this work, we propose a slightly different interpretation, that those minor variations are not irrelevant, and that latter proposals are refinements of prior gestures which preserve the gestural features that matter most to users. This would suggest that features which are constant across refinements are more semantically salient. Additionally, we believe that a motive for users to refine a preferred gesture is to make it more natural and thereby less fatiguing. To explore this interpretation, we conducted a 2-hour study in 2 parts, with each part lasting approximately 45 minutes. The first part consisted of a gesture elicitation study for full body interactions with a public display using unlimited production. Unlimited production enabled participants the freedom to explore gestures and their variations through iteration on preferred gestures in a way that other production methods may have not. The second part of this study was a retrospective, where the participants were asked to look back on the gestures they performed and evaluate them. The retrospective was aimed at reducing any ambiguity in the performance of the gesture by allowing researchers to ask participants clarifying questions. It also allowed researchers to identify gestures which were considered refinements of previous ones. We recruited 22 participants from the larger university population. All participants were right-handed and had various levels of comfort with technology. The study was conducted in a lab with a large projection display, and the surrounding area was large enough for the participants to move around in. At the start of the study, the participants were told to pretend they're in a shopping center when they come across an interactive display providing information about national parks. They've always wanted to visit Yellowstone, Glacier, and Grand Teton National Park, so they decide to learn more about what there is to see and do at these locations. Participants were shown referents related to the scenario described that included interacting with photos of animals and landscapes found in national parks. We did not stop the participants from generating any gestures if they still had ideas, nor did we set a target number of gestures for them to produce. We also didn't give them any instructions on how different gestures should be, and we instructed them not to constrain themselves to current technological limitations and to pretend like the display could recognize any movement they made. They were asked to think aloud during the elicitation part of the study and to start by standing. Once the participant ran out of ideas for gestures to perform for a particular referent, they were asked which of the gestures for that referent was their favorite and least favorite, like in the original study. Throughout the elicitation, participants were shown 10 referents. The first referent was used to get people familiar with the task and therefore was not coded. The order of the remaining 9 referents was randomized and included actions such as paging right, dragging an object, scrolling, selecting, and deselecting an object and zooming in and out. In the second part of the study, experimenters conducted a retrospective with the participants. The goal of the retrospective was to clarify any ambiguity observed during the elicitation, to gather user ratings of each of the gestures without inhibiting their creative flow during the elicitation process, and to identify whether participants thought that each produced gesture was independent of the others or a refinement. To prepare the gestures for further evaluation, we performed 2 coding tasks. We first segmented the gestures and then coded them by identifying a combination of hand orientation and the movement of various body parts like in animation keyframes. In our analysis, we found that production made a difference in user preference. We see this through the combination of two results. First, users needed to try a few times before finding gestures they liked, as shown by the distribution of favorite gestures across all productions. As with the first study, participants preferred their third gesture on average. Additionally, 34% of gestures occurred beyond the first three, and there was significant variability across users, with some users having a strong preference for their first gesture, while others preferred gestures equally likely to fall towards the beginning or end of gestures they produced. The second result that supports the impact made by unlimited production on user preference is that favorite gestures had significantly higher appropriateness to the action, guessability, and ease of performance scores compared to other gestures. These results confirm those found in our original study and reinforce the value of unlimited production. As mentioned, the addition of the retrospective in the second half of the study allowed the experimenter to explicitly ask participants whether each gesture was a refinement of a previous one, and if so, which one. This resulted in our ability to identify that about 10% of gestures were not new gestures suggested by participants, but refinements in which users were iterating on gestures that seemed promising. In this example, we can see the distance between the start and end of the gesture decreasing and the palm direction and trajectory of the swipe changing. This refinement in our methodology, in combination with the fine-grained qualitative coding that was conducted, allowed us to identify features of the gestures that do and do not seem to matter to users. Our results also indicated that some specific features, such as palm direction and hand configuration, contain a large amount of variability and are not distinguishing characteristics for users. Additionally, real-world variability of gestures is much higher than the variability found in most pre-recorded gesture datasets. Here are 4 examples of a push gesture performed by different people in a precise manner for a TV control application. This level of precision is not something that people tend to have in normal interactions with technology. These findings have direct implications for gesture recognition algorithms, the variety of the data they're trained on, and the way that data is labeled in supervised learning approaches. In this work, we highlight the value of unlimited production and a retrospective phase in elicitation studies. We show how refinements can shed light on participants' mental models by identifying the gesture features that matter most to users, and finally, we discuss implications for gesture recognizers.